All right, so let's continue. Yeah, let's continue. So see, we've gotten this, and there's a question that said justify. But please remember that we have our graph to be r squared against, hope you know that is what slope means. Divided by, that is y over x. So divided by 1 over t, which is essentially saying r squared times c over 1. Hope you know. Which is essentially saying r squared t is our slope. Are you aware? Oh, sorry. You are aware of this one, Shebi? Yes. Is it t squared or t? Just t, Shebi? Yes. We use it. By right, it should be born. Let's go. Let's see. Let's see. Velocity. Do you remember that velocity is the same thing as displacement over time? Yes. Shebi? Yes. Somewhere they can tell you AB. Somewhere they can tell you that the distance is height. They can also tell you that the distance is from M1 to M2. Do you still remember how we did this practical? Whichever one given to you is still talking about the displacement. That time we did the practical now. That is this one that we analyzed here now. Our S is simply A to B. This thing means A to B, the edge. So I'm showing you the different things you can see as your displacement all over T. So if I put this thing down instead of VT, and I see, or even they can say it's just AB, whichever one. Now what I'm saying is that instead of putting this thing, because of the fact that the graph given to you is that of 1 over T, normally this practical is always the type where you do velocity against r squared. But a situation now where they've now told us that we are to do 1 over t, r squared against 1 over t. So we need to first of all set this thing. If you look at this first of all, using this thing this way, it simply means that this is supposed to be our y, normally. And if I remove r squared that I'm seeing here, thinking of it, 2g and everything here is supposed to be my m, and r squared is supposed to be my x, if you remember. But since that is not how we are going about it, we'll see what we do. Why normally the equation of the straight line is mx plus c, if you remember. So we are trying to compare. So what I will do is to say, let me use s as my displacement. So s over t as my velocity, sorry. So I will now have 2g, watch out, rho s minus rho f. Times r squared all over 9n. Are you still with me? Be with me.
You are not we talk about.
Don't worry, Papa is outside. Do you want to go outside? But see, I said what I just did is I carried the r square out because I am not using my initiative. Since the graph they said I should plot is r square against 1 over t. Shebi, I am not trying to make it adapt to this thing. It's more like I'm dancing, but I'm dancing towards this because I have something I want to achieve. So I am not saying carry the r square one side where it will stay like x or y. You know that in this case r is y, Shebi? So that I can be able to make r subject of the formula. And this 1 over t will now become the x. So that is what I'm trying to do. So let's see. So I put r square one side, put everything here, the same side. So I'm now having, if you look at it, everything, if I'm comparing this to the equation of a straight line, this is something that's saying mx. Then y equals to, but I notice the way, I don't want to because we're on camera, but most of the time the things we do here will include both the one others are doing and the one we want to do. Yes. So that setup we must adapt to it. To adapt to it simply means I will now come and do comparing your manual to what normally is. But however it is. So if I say let's cross multiply Hope you know that if this thing that you have here is certain as saying S times 1 over T, shall we?
Yes.
So if I say let's cross multiply, and this now will quickly go down here. Shall you know, this S now, see, hey, because of some people. If this thing is like this, S will quickly come here. Is it not true? So I will now have 1 over T is equals to 1 over T is equals to 2G rho S minus rho of fluid R square all over 9 eta S. Are you aware? Yes. What there? Look at it with a spiritual eyes. Eh? If you look at it with a, what I'm trying to do is, I don't want to do that method of I come and say, this one come here, this one come here. It's suffering myself. What I'm saying is, instead of cross multiplying the T, just carry the S on top. If you carry that S on top and come here, if this S come back and times this, is it not S over T?
Yes.
That is what I've done. But if you want it the way you like it, let's do it.
No.
Shall you see, it's them that is your enemy of progress, not me. So we'll continue with this one. So I'm not saying, since they said that this one should be on the vertical side, and this one should be on the horizontal side, and we know that anything that is here is this one, and everything here is this one. Why? Everything here is arrow square. But that is not how they said we should plot this. Rather, they said that we should plot this one to be on Y, and this one to be on X. Magic. So, can I claim?
No, wait.
Be fast. While we try it out. So it's more like we are rotating it. So let's say I call this 1 over T equals to M R squared. M for slope. No, everything I say we'll do it. That's what we've learned room. See, if you look at what I'm doing here, I've already drafted what it should be. So we'll do it. What I'm doing is I'm running from, we don't understand. That's what I'm running from. So we are in line and everybody understands this one. So you are correct too. But when we don't do it now, this you see works.
Assuming, why can't we just substitute? Since the array is on the y-axis, substitute everything and go.
Substitute everything and go.
Yes, put the array square, y-axis. Give it array square is equal to
See, shall we know some of you when you talk, you are saying it's how you are talking to your child in the next 12 years. Yes. Once they do, you submit your paper and start coming home by time. So please, it's true, that is what we are going to do. But we don't rush to it. This thing we are doing is like the procedures. So we don't make mistake. And maybe put and then we made mistake. So we are following it usoro, mathematical usoro. So we will definitely get to that thing you have upstairs. Is what we want to do. But we are following it by the pattern it should go through. Okay, so see. Notice, so this is where we are, shall we? Okay. I want to clean this. Since I know that the equation of the straight line is equals to y equals to mx plus c. C for intercept. If I know that, what it means is that right here for now, 1 over t is my y. Shall we? Equals to 2g, shall we? Rho s minus rho f, then all over 9n, shall we? And s is my m, is it not true? And r squared is my x. Don't ask me what of your intercepts. We know that normally y is also equals to mx and y is also equals to c. Are you aware? Yes. From the rules of dimensional analysis. So this c now that is not here, I can get it from my graph. Now see, and we've taught you how to get intercept from graph. Now see, I can say let everything that is here be equals to m. So if I equal it to m, I'm now having r squared. So let's 2g rho s minus, please do it in your notebook like this, so that as you are reading, it's easy for you to remember it. 9 eta s equals to m. So if that is the case, that means I'm now having mr squared is equals to 1 over t. So if that be the case, you can see that I can now choose because I want r squared to be on the vertical axis. So to make this other form, I'll say divide both sides by m. So divide both sides by m. So if I do that, you will see that this is the sentence I'm saying times 1 over m. Do you agree? Yes. Times. I notice that the reason why some people will say they don't understand is because we normally miss some steps thinking everybody's there. But now we'll be doing things without which each other. This one now. So r squared now will be the sentence as saying equals to 1 times 1. Shall we? M times t. Now notice something. Notice something. What this thing means is that if I'm considering my slope now, this is the sentence as saying r squared is equals to 1 over your slope times 1 over t. So that means that for this graph, the slope is actually 1 over the slope. That is, for this to be on the vertical axis, it simply means 1 over the slope, because remember that this is 1 over n. So I will now come back and now substitute. So everything here is the same thing with what I have here. I just drafted it so you'll be able to. Okay, you can see it down. Let me write it. Shall we stay on?
No.
You soon leave the front seat. Right? So that people that can see road will come and occupy them. Oh, yeah. So I said, what I wrote there is simple. I said r squared to be equals to 1 over m times, I'm using that over, times 1 over t. So it simply means that if you now check this is now your y-axis. Then this now is the sentence as saying 1 over your slope times 1 over t. And everything here is simply the sentence as your x in this case. Now, what you will now do is to replace the m with the value. So this is the sentence saying y equals to 1 over, remember that this is 2g rho s minus rho f all over 9 eta s, fear not, we're going to do it the way it should be, times 1 over t. You know that the reason why this is having inverse is because they reversed it. The question instead of reversed it. Are you aware? Normally, it should be 1 over t at the vertical axis r square at the horizontal axis, or the velocity at the vertical axis and r square at the horizontal axis. But whatever the examiner asks you to do according to that question, that is what you are doing. So them telling you that r square should be on the horizontal axis, on the vertical axis, and 1 over t being on the horizontal, simply means you are reversing. And that is what is playing out here. So if that be the case, this is the sentence saying I have y equals to 1 divided by, hope you know, 2g rho s minus rho f all over 9 eta s. And that s is for displacement, Shebi. And you know that if I choose to introduce, why I'm doing all these things this way so that you don't miss any step and get confused. If I choose to introduce that reciprocal power law, if I introduce multiplication here, this will reverse. So if it's reversed, I will now have, you can see here, Shebi, those of you at the back, I will now have 1. I can clean this. Just this side. Yes. Okay. So I now have y to be equals to 1 times 9 eta s all over 2g rho s minus rho f times 1 over t. And we know that anything times 1 is what? That thing, Shebi? Yes. So it's simply that y, and we know that our y is what? R square, Shebi? Yes. So please, I will now come and remember, replace this with R square, because if I can use all this y, you check for, you're going to be saying, how did he now put y? So R square, so R square is now equals to 9 eta s. I need to clean this. 9 eta s all over 2g rho of sphere and rho of fluid times 1 over t. Please, that question, this is what they want you to do. Wait, madam. So if we finish this now, this is simply the y. Everything here is simply the m, and everything here is simply the x.
Very simple. Suppose going through all this thing, why is r squared? You put r squared axis. It's on y axis.
How did you say that? It's true. It's true.
If you put it, it's just still the same thing.
It's true. Do you know that when you've learned something, like when you've learned something properly, especially when it has to do with physics, it's not easy for you to go through any angle, rotating, telling yourself you can do it this way, do it this way. Reason, because you are still on a good foundation. But when it is not you've not encountered that proper way to go about it, and you start doing that your magic, you see that you enter trouble. So this thing we've done here is what we call going through the right procedure to come about it. So whichever thing you are now doing is now what we refer to as manu. That is what we now say you do the manipulation. So but the right thing to do is simply this thing. Let me look at that your manual again. You have question? Well, if you have question, ask me. So notice, this person's old. This person's old, they gave this person time. Shebi? This one is the new one. But the old one, no time. Oh.
The lecturer gave.
Okay, the lecturer gave you time.
Yes, but that value, I think that value is small because it's not a straight line graph.
Yes, now that is another thing. If you make mistake with your time in this thing, if you remember when we started with things like the denser, the lesser the time. Shebi? Yeah. So if you just maybe you presume and you are not doing, maybe you have this one to be, let's say you have 0.15 as your radius, 0.20 as your radius, 0.25 as your radius, and maybe somewhere because you like things going from positive increasing, you come and do maybe, yes, if you do 7, 8, 9, you are in the right order. I hope you know. Because this 0.25 should be greater than this now. Greater than this. Am I right? Check. Yes. Yes, right? I see. Notice that the 9 is greater than this and this is greater. But let's say you come and look, for example, 7, 8, 9. You see that you are going against it. Why do I know this? I'm checking it that if the mass is higher, it possibly means that density will be higher. Because if you check the formula for density, it's equals to mass over volume. Anytime you see something and something on top, it means that they are directly proportional. An increase in mass means an increase in density. So let's use this person's reading to see if we can fill up the table. So we've done the first we've done number I. That is this one. So let's use this person's this thing. Fill up table and look at some questions. Let me see that your old one. Okay, okay, now see. If you notice, please go and look at something. That's VI. You see that what they have there, 9NS, all over 2G, this thing that they have here, do you know what they're saying?
Put P minus that 0 times.
Yes, that P minus 1 0. Okay, yes. That thing that you see is more like, the first one stands for density of sphere. The second one stands for density of fluid. Now, do you know what that thing is saying? That C is simply equals to your slope. That C you see there. Notice, that C there is just equal to your slope. So we are going to be doing all those things. So now let's go. Let's go to the table. So those of you that if you have the one that is page 168, if your own is page 168, that is, you are having the old manual. Please, as I draft, you'll be checking if the table is the same with your own. Like, I mean the given thing, the given parameters. Do you remember I said R plus? I told you anything plus or minus is increment, decrement, Shebi? Yes. And it's the set and standard error. Very important. I can clean this. I can clean. Help me, please. Thank you. Let's clean this so that we have enough space. Remind me after what they say, so that you'll be able to know anything, even if you'll be able to know the question, how to go about it. You don't start trying to plan it.
Okay.
Hope you know that this is the sentence 1 over T.
Yes.
I miss one value. Okay, yes. Sorry. The 3/8 code. So please, those of you with the old one, is it the same?
Yes. Yes. But the time is different. But the man gave us time, like you gave us.
Your one doesn't have time. Let me see your time. Okay, the lecturer for the old one.
Yes.
Was he the one that said you should put 0.5?
Yes.
Okay. Let's work with it and see what it will give us. Our advice, you always use pencil when doing anything inside your workbook, inside your manual, so that you don't go and make mistake and start using correction fluid inside. Okay, yes, this IV is tricky, but I get it. Okay, so let's look at this. We've done these things before, but it's just that some of it, we did upload it then. But this time around, we've decided that all the videos must be uploaded. There are times when you just finish, you say you upload it later, before you know you delete the videos. But now, anyone I do, I make sure I upload it that night. So this thing now, I upload it this night. Okay, so R square, just do for me, let's be fast. 0.2793. Square it. This one, this R square, check first of all. Did they tell us to convert to meter? No. That means that the unit here is centimeter. And do you remember that in this square, thank you, yes, God bless. And do you remember that in doing this practical, our main goal is finding terminal velocity. Are you aware? That means anywhere we see V, that means that V is in what? Centimeter per second. Hope you know. This is in second per second. Now this is length R, is still in centimeter. This is length T, is in seconds. You can't have length centimeter. You won't get it like that. Well, punch for me. 0.2793. Square it, what do you have?
0.078.
0.078.
Okay. So please, those of you, when you're watching on Zoom, we'll be checking. Please, before we use this thing, this time in correspondence check, which one is the least time here?
0.55.
Is it the least time?
Yes.
Okay, that's the least time. Are you sure? Check.
Yes. That's the least time.
It's the least time.
Yes.
Okay, so which one is the biggest density here?
0.24.
I'm talking about density.
0.4240.
Okay. That means what you're trying to tell me that 0. Okay, yeah, it's true. It's true. I've seen it. This one is 1 point. I'm imagining it from an angle. It's true. Okay, so you see that it corresponds. Bigger time, bigger density, right?
Yes.
Lesser time. Okay, it's correct. That means the time given here corresponds properly. The lesser the density, the greater the time, or the longer the time. So, do for me 0.29900.
0.0841.
This 0.78, is there any other thing remaining?
Yeah. 0.
Okay. But notice, should we remember that when we started, we normally say, let's get our things to 4 decimal places. Should we? But notice, time is spoiling it for us. Since this one is already given to us in 4 decimal places, should we?
Yes.
This one, they gave us in 2 decimal places. Somebody said it's a must. No, is it? It is. I will put. Okay, the third is not a must.
Yes. Everything is that code is in the same decimal.
Be playing. It's like you did not do WAEC. You did not do practical in your WAEC. In my own WAEC, when I did my own WAEC and jump, the decimal, sorry, my own WAEC, the decimal place must be uniform. If I'm using 2, it must be uniform. So please, if you choose to use the one you want, no problem. You say for what? It's a very big lie. Anybody telling you that, there is how you compare informations you get. There is what we call detailed information. And somebody giving you information because he's in a place of authority. If I tell you, you must agree. What I'm telling you is something you are free to go and verify with different sources. Not that they told you. If I'm using a decimal place for my practical, it must be maintained, it must be uniform. And also, if I'm numbering this in units, I cannot repeat this thing I have here, down here. Once it's here, it covers for everything. So it's something that must be maintained. So if yours, you choose to ignore it, it's up to you. Okay, do for me 0.3465.
0.1201.
0.1201. Okay. 0.3836 times 2. That's times
0.1471.
147. Okay. 0.4240. 1797. Okay. The velocity. Are you aware? From our graphing, our practical, did they give us distance?
Yes, it is.
Okay, so if they give us distance to be 80, let me look at it myself. Get it? Please, let me see the old one. Coefficient of viscosity. Okay, they gave us coefficient of viscosity to be 0.29, Shebin. Then specific gravity, 12.4. Let me see the old one. Let's check what they gave us here for distance. Okay, 80.0. Okay. So what that means is simply, I will simply remember that velocity is equals to displacement over time. It is equals to height over time. Are you aware? So what I will then be doing is to simply say 80 for the first time all over. The first time there is 1.24. Yes. Which is essentially as 1.240. Oh yeah, do 80 divided by this one.
64.5161.
64.5161. 5161. Shemi?
Yes.
Okay. Madam. Okay, please. That is for V1. Shemi, I do for me V2 80 divided by 1.5.
69.565.
69.565. Oh yeah, that is 652. That is how you be doing all of them and be calling for me. So 64.5161. Then 69.5652. Okay.
98.7654.
7654, yeah? That is, if you do 80 divided by this time.
121.2121.
Okay, 80 divided by this time.
145.4545.
Okay, so inverse of your time, that is 1 over 1.2 for what do you have?
0.8064.
8064. 1 over 1.1500, do fast.
0.8696.
Like this, shall we?
Yeah.
1 over 0.8100.
1.234.
Let's be fast. 1 over 0.6600.
1.5151.
1.5155.
1.8181.
1.81. Okay. Lane. Natural log of R. That is natural log of 0.2793. Give me.
Minus 1.2754.
1.2754. Natural log of 0.2900.
Minus 1.2378.
2378. So give me the next one.
Minus
1.0598.
I'm coming. Is it this one? That is not t square, but 1 over t. Okay, 65.
Yeah.
Okay. Thank you very much.
Minus 1.0598.
Okay. Natural log of 0.6600.
So that's not that. It's this one.
Sorry, natural log of 0.3836 though.
Minus 0.9581.
598.
No, 95.
Come again. 0. Come again.
0.95.
0.95.
1.
Okay. 82.
1.
Is it 2 or 1? 1. Give me the last one.
Minus 0.8580.
Minus
580.
So please, why I'm taking time to do it is because of this video. So those of you that will need it in future, you go there and check. How did we get? You go and check it there. Lane T.
0.2151.
Lane 1.500.
0.1397.
Lane.
Minus 0.2107.
Wait, this one's 0, Shebi?
Yes.
Then this one is minus.
Minus 0.2107.
Minus 0.10.
2107.
Okay.
Minus 0.4155.
Okay.
Minus 0.5978.
So we have our table. So that's the table. So let's look at the IV. From that question, let's look at the IV. We've touched II. Let's look at the IV. Let's look at the IV. They said obtain the slope of the graph of number II. So now see, give me, first of all, we got R squared is equals to, give me what we have. 9 theta
S over 2G rho S minus S.
rho S that's 1 over T. Okay. So that means we say that everything here is the slope, shall we? Let me just put this one. So then everything here is the X and this is the Y. So but they are asking me to obtain the slope. Obtain the slope from my graph.
Yes.
Shall we?
Yes.
So I obtain slope from my graph. Okay. And equate it to the expression containing 9. This expression is it having eta?
Yes.
This expression is it having eta?
Yes.
Is it having S for displacement?
Yes.
Is it having P? That is The densities. Shebi is having it. Because this one stands for that density of solid. And the last one there stands for density of fluids. Shebi? If that be the case, notice that they did not tell me 1/T, Shebi. What that thing is just telling me, that English you see, they are speaking there. What they are just saying is that I should make, from this, make this and this subject of formula so that it will be equal to this. So that is the sentence I'm saying, arrow square, divide both sides by 1/T. Hope you know that 1/T is the vertical axis, Shebi. What that question is saying is that when you get this thing that we've gotten as the equation of the line, hello? Listen to me now. See, Shebi, this is the equation of a straight line. This part represents M, this part represents Y, and this part represents X. What they are saying is that we should divide both sides by 1/T. Do you remember that our graph is actually arrow square divided by 1/T? That is our slope now. Is it not true? So if I divide both sides, you know that if I divide both sides by 1/T, this thing will be cancelled out. Shebi? So let's do something. Let's do what? So we demonstrate it. I have arrow square equals to 9 eta s all over 2g rho s minus rho f. Then I have 1/T. Then divide by 1/T. Divide by 1/T. Hope you know that this is the sentence I'm saying T over 1 times arrow square. Do you agree? Yes. Basic mathematics is equals to 9 eta s all over 2g rho s minus rho f 1 times then 1/T. We can do just over T, but so that we don't confuse it. Times T over 1. Shebi? This can cancel this. Now notice that anything over 1 is that. So we now have T arrow square is equals to 9 eta s all over 2g rho s minus rho f. This is what they're asking you to do there. Just this thing. Very simple. So that is what it means is that see what it means. What it means is that the slope that you have here, hope you know this is your slope. Because by the time you do arrow square divided by 1/T is the same thing as saying arrow square times T over 1. Are you getting it? So this thing now, everything here is your slope. What that thing is saying is that your slope, that is your slope, what you get as your slope, whatever you get as your slope for your graph, should be equal to 9. That is slope from graph. Slope from graph. Whatever you get as your slope from graph, if I get maybe 1.2 or 1.8 or whatever, should be equal to 9 eta s all over 2g rho s minus rho f. So that is just it. What you just doing for me there is, if you come and if you are truly correct, by the time you get a slope in your graph, if you just come and substitute all the values you have for this thing, it should be equal to what you have in your graph. Let's say I get 1.5 in my slope. I come and write it here. I just focus this and I'm not equating anything or trying to solve. I just come, for example, and say coefficient of viscosity given to me is 12.4, Shebi. What else? 0.29. Where was it given? Okay, 0.29. I substitute. I times my displacement income 8 Shebi in centimeters. I times. Now, all over 2 times 9.8. Density of sphere, was it given? Was the density of sphere given? Yes. 0. What? 12.4. Okay, in dropping bearing of specific gravity into I'm seeing for liquid density is 1.4. Shebi? Yeah, then the ball, they didn't give us the ball.
They gave us.
Where is it now? It's specific gravity, but I just want to believe they are trying to equate all those things we improved when we started with that English there. So if we substitute the ball to be 12.4, so that of the sphere, you know that is the sphere there. Then that of the density of the liquid, which is, Shebi they said we should use castor oil. So liquid density to be equals to 1.4. What we are saying is that by the time we substitute all the things we have here, what we have here should be equal, exactly equal, or just more close approximation to whatever the slope gives us. Are you understanding it? That is just what that IV is saying. They are not saying you should solve anything. They are saying what you've gotten in your graph. Come and check if it is actually true. If I solve this thing, if it will give me the same thing. So left hand side normally should be equal to right hand side. That is just what they are asking me to do. Very simple. So this is the equation they expect you to do there. So when you've done this equation, so going further to prove it, you now come and prove to your graph. Check if your graph, the slope of your graph is equal if you substitute. If it's not equal, if it's far away, that means slope of your graph, you need to really check it. Okay? Now they said, I want to now claim this. They said, V, calculate the slope, calculate from the slope, the acceleration due to gravity. Okay? Can I claim?
Yes.
Be fast. Let's be fast. They said, hence, calculate from the slope the acceleration due to gravity. Can I claim?
Yes.
Okay. You will see it inside YouTube video. So if you did not copy it all along, so please, if you like, when you are doing your own Chikobi, you come and do, you cross over, how can Sir say, you just go and point slope to be looking at something? It's you that know. Please, slope, you just write your slope. You are not solving anything. It's actually more like saying, check if your slope is correct using the things you have here. This is the question you are presenting. Your questions are never straightforward. That's why once you start asking questions for us, don't worry. See what I'm saying. But see, let's check something. Because of your question, let's try to analyze this. Please listen. Let's say you've done your slope and he gave you any value at all. You are the one that knows the value you have, Shebi? Yes. Equals to. Now, 9. What did I give as the coefficient of viscosity there?
0.29.
0.29. Like this. Okay? The displacement. Remember this thing is in centimeters, Shebi, you know. That means that acceleration due to gravity there has to be converted to centimeter. Are you aware? Okay, so 8 in centimeter, let me put it so that we don't forget. Okay, then divided by, please, Chico bees, listen, the gravity there is 9.8 or 10. Did they tell us what to use?
9.8.
9.8, always pay attention to that. This 9.8 is in meter. Are you aware? So, to centimeter, first of all, 1 meter equals to what? I will always do this thing. I have my reason. If this now will now be equals to x centimeter. So cross. So that we now have 9.8 times what?
9.8.
is equals to, hope you know this thing means equals to as well, but in chemistry, is equals to x centimeter times 1 meter. But what we want to do is to convert to centimeter. So let this cancel this. So I have x centimeter, 9.8 times 100.
980.
980. So I have 980 centimeter. I've done this thing like 100 times. I even gave you a list of all the units and how to convert it. The conversion table. But some persons don't say, and I know you don't know it. Oh yeah, the density of sphere, we got it to be 12 points. Minus 1.4. Okay, and remember that 1.5 and 12.4 is in gram per centimeter or kilogram per gram per what? Gram per centimeter? Okay, because if you fail to do it well, you will enter trouble. Oh yeah, you're the one that gave me. Thank you. So now see what I'm saying. Whatever thing you have as your slope, I don't know it. But the one I want to know is that this is the same thing as your slope. If whatever you get from this, your slope from graph is far from what you have here, that means your graph, something is wrong with it. That is the summary of what I'm saying. Now, punch for me. And remember, please, remember that if there is anything in that our arrow square that we are using, Shelly is centimeter too. Our arrow square is centimeter as well. Okay. Please punch for me. 9 times 0.2, 9 times 8, what here? 208.8. Okay. Divided by 2 times 980. 2 times 980. 19. Like this, Sherry? 11. I have punch for me. 1960. 2150. Like this?
Yes.
So, punch here. Punch it for me.
9.6846
68
46
and
0 1 1 1 1 times 10 is 1 minus 3.
times 10.
Is 1 minus 3.
Okay, which is approximately.
0.
Mbana, don't worry, I want to do this one first.
9.7 times 10 is 1 minus 3.
Sherry?
Yes.
And do you remember that your slope is actually, remember, your slope is r squared divided by 1 over t, Sherry?
Yes.
Which is the same thing as r squared times t over 1.
Yes.
Sherry? Which means it's r squared c. Sherry?
Yes.
Which means your slope is actually in centimeter square seconds. Are you aware? That means that the unit of this, please watch equal. The unit of this is actually in centimeter square seconds. Hope it's making sense to you. The unit of your slope is determined now by what you are doing on the vertical and the horizontal axis. So that is what I've noted here. So please, if you now want to convert to meter square per second, you can also do it using those numbers. What did you say? Which question are we solving? Okay. So please, the one we are solving is IV, Shelby? Is it V? No, it's IV now. It's IV. We wanted to move to V, but somebody don't call us back. We don't say let's not move it. Like, it's this thing that we are still doing. We wanted to move to No, we wanted to move to V. Shabi, this one is still IV.
Yes.
Yes, we are still on IV. Wanted to move to V, but somebody asked a question. I now said that you don't have to go home and start maybe, if you come and put your slope from graph here, you start using it to interchange. And I said what it means is that by the time I finish everything I am using that part to do, it should equal to this side. And this side is the slope I got from my graph. So let's say in my graph, I should be having like 9.7 times 10 raised to the minus, or you can be having 9.5 close to it. So by the time you take your left hand side and right hand side, they are equal. That is what that question is saying. Your graph, you got 9.9. Your slope, you got 9.9. You are close, but you need to check. If you check it well, somebody that got 9.7 and 9.9 is still close. Check. You got percent space comma 2 because did you convert your G to centimeter? Check your G. Some of you are using G as 9.8 instead of 9.8. You are forgetting that G naturally, that 9.8 is always in meter. Your G, when you are doing this, remember we converted to centimeter instead of 9.8 for a reason. Oh yeah, let's move to the fifth one. Oh yeah, be fast. Let me look at your money. Listen to what I'm saying. What they're saying is that you should obtain the slope of your graphs, which we've gotten. Now they say equate it to the expression containing, and the expression containing is that time you've gotten your slope. It is equal to all these expressions. You equate it. Now substitute, which we've done here. You get an answer. Whatever answer you have here should be equal to the answer you get from the slope of the graph. G is normally a constant 9.8 meters per second square. But because we are doing something in centimeters, you have to convert that 9.8. I don't even understand why you people are refusing to understand this. See, there's nothing like Shebi, the answer ended here. All this thing I'm doing now is for you to get an understanding that if you stop here, this is an expression. Now, when you have come here and check your graph, and your graph is not actually equal to what we've done here, it means that you coming to do this thing, you are wrong. Let's say you come now, I've got 9.7, you are getting 12 point something. You come and say 12 point something is equal to this. Is it normal? No. So what it means is that if you are doing this thing to stop here, you must make sure that you are using this thing to check that what you are equating to this, those expressions, is actually this on the other side. If you don't understand it, leave it. Yes. If you don't understand it, leave it. I've explained it how I should. The only reason why you don't understand it is that there is something you have in mind that once you want it to happen that way, outside what I'm saying. Because what I'm saying is just straight English. Do it like this. Use this one to check it. So I can now come and just say that slope is equal to this when I've not checked to see that the answer I have is actually truly equal to what these things will give me using what I have in that book. So let's move to the fifth one. Number 5. Number 5. They said, hence, calculate from the slope the acceleration due to gravity. Hence. I want to clean. But let me say. Once it knocks 4 or 5 now, You will not even want to consider that we not finish your question. Okay. See. They said, hence, my friend, when you watch the video, rewatch it, you must understand what I'm saying. Hence, calculate from the slope, the acceleration due to gravity. See, I have my slope here. Equals to what? Those things, give it to me. 9 Chevy, eta S, right? This S is for distance, so we know. Because some persons will confuse it as slope. There are some cases. So all over 2G. Bracket, Chevy? Rho S minus rho. Now, they are telling me to check from this if acceleration due to gravity. What that question is saying in summary, we know that acceleration due to gravity is a constant, Shebi. What the question is saying is, in summary is, make G subject of formula from this thing I have. Using, it's more like, let's say you've gotten your own graph to be like 9.7, the slope of your own to be 9.7 times 10 raised to the power minus 3. The slope of your own, that it should be equals to 9 eta displacement all over 2G rho of sphere, density of sphere, and density of fluid. That is what they are telling you to do there. That you should use this thing to check your graph, your slope in your graph. That you should use it to check if everything will still give you 9.8. That is that value that G has as a constant. So that is what they're trying to do. So what I will simply do is, how do I make G subject of formula here now? So I will say all over 1. If this go here, it will be the same thing as saying 2G rho S minus rho F. Then I have 9.7 times 10 raised to the power minus 3 equals to 1 times this 9 eta displacement. Are you seeing it? Now, if I want to make G subject of formula, it's the same thing as saying single G out. Hope you know. So I will divide both sides by everything that is not G here. So I will divide, I'll say 2 rho S minus rho F. Into so you see this everything, and we didn't include okay, yes, this will cancel everything here. So I'm now having G to be equals to 9 rho 9 eta displacement all over 2 rho of sphere minus rho of fluid, then 9.7 times 10 raised to the power minus 3. Okay, so now at this junction, shall we check? I hope we did not make any mistake. No. Okay, so G will be equals to 9. What did you get your coefficient of viscosity given to you? What is it? 0.29. Okay, the distance is C and Chevy all over. Okay, 2, what is this one? 12.4 minus 1.4. Okay, then I have 9.7 times 10 raised to the power minus 3. So that I now have G is equals to, I have points for me. The points, the all. 208.8 all over. This one is 2 times, you got 11, should be? Yes. Okay, then times 9.7 times 10 raised to the power minus 3. 0.2134. That is it. 2 times 11 times, is it? Yes. You got? 0.2134. 0.2134. 2134. Okay. 1 point, show me what do you have?
978.44.
978 and
Point 44.
point
44.
44
42.
and
362.
Ogu, like this. Finish. Okay. And you remember that this is in centimeter and second square. Sherry? If I now choose to convert this to meter, let's check. Can I claim? No. Be fast, be fast. If you like, when you reach exam, you go and do what you like. You forget all the things we've been doing. Remember that if they will not, I don't know if they have told you. I don't know if they have told you. But let me tell you. If you fail the practical of any course, thank you. I normally forget. I'll collect it back. If you fail the practical of any course, let's say you get F in physics 107, and you go forbid, it's not for you. Those people not coming for tutorials. We are imagining now. Okay. Now you see yourself. But something you'll be doing me. What if? I'm doing my own what if now. So you can see. Somebody must get F now. Hey, you can see. What you see? There is F. F. Now this F in physics 107 by somebody. Now this somebody now come and get A in physics 101. Remember that this one is 107. This one is 101. They don't have business, so sure you know. But when they want to give this person A in this one, that is A in this one, because this person failed this one, the person failed this one as well. Did you hear what I just said? Shebi, you see, they don't have business, so this one is different, Shebi. This one, the name is 107. This one is just 101, Shebi. But because this person failed this one, they are assuming that this person failed this one as well.
If you fail 101, will you fail practical?
No, they won't have business. Let's say you get A here and you fail this one, nobody send you. Okay, that's the same thing. What I did is just I passed the information. And it's up to you now to believe or leave it. Yes. So please, why am I saying this? It's important you take it that the practical aspect, if you go home, you practice it. Try your best to practice it. And practice it and it becomes part of you. But please, let's try, remembering what we are doing, that we've covered units and dimensions. We're trying to convert that 978 centimeter per second square.
9.78.
So if you convert, you have G to be equals to 9.78, 44 meter per second square. And you remember that this is approximately
9.8.
Shebi, you know? Meter per second square. So that means we are correct. Oh yeah, well, let's look at the next question.
Next question. Show that
Okay. And that thing is negative, oh. Negative half, Shebi.
value. This is how it was.
That's you plotted arrow square against T. Then use, but if you notice the T is not working, you use the T for those people and this one that we are doing. But you tell him, maybe somebody or your course rep, anybody, or did they share you people by group? Okay. I'm thinking if possible, they share you people by group, then you people go and tell him that it's not corresponding. So possibly you use this one, because this one, everything is working well. Because that one is looking strange. It's just moving one side. It's flying. Yeah, the values are flying. Okay. The VI, they said, show that lane R is equals to negative half lane T. The problem I'm having with that, with lane T that I'm saying there is that, yes, but the problem I'm having is that if you check it from all indications, it's supposed to be